right, guys, this is the second topic for applied genetics on pedigrees. Pedigrees are a chart that shows inheritance patterns in lines. It could be for humans. They use these for dogs, for breeding. Or, you've heard of people talk about what's your pedigree, and that means who did you come from and what are your, what's your background. Now you have a table and it looks like this. Kind of put this underneath here where it has all of these symbols. So I'm going to hit the main ones in this table over here, but the table that you have in your packet is for reference. So it's a little bit hard to read, so I'm going to rewrite some of these. So a box is male and a circle is female. And you can remember that, but you think of girls as having curves, right? So girls are always circles, females are always circles. All right, you start off with parents, or this indicates a marriage. So these two got together. And when there's lines that come down like this indicates, so the word next to this is offspring. So we have two parents, and they had 1, 2, 3 children. If you are black, if you're no color, you're normal. If you're black, you have the disease. And if you're half colored, you're a carrier. And then you'll notice that there are Roman numerals here. 1, 2, 1, 2, 3, and 4. These represent generations. And then something else you might see are numbers 1, 2, 3. So what they'll do is they'll number people in a generation. So the first generation has 2 people. This set of parents had 1, 2, 3 children, and 2 of the children got married and had offspring. They number them 1, 2, 3, 4, 5. So when we answer a question, we can go to the generation and then the number. And I'm going to go through this with you as kind of a way to explain these pedigrees. So question 1, how many generations are represented in the pedigrees? Well, we've got 1, 2, 3, 4. So the answer here is going to be 4 generations. In generation 1, which parent is heterozygous for the recessive allele? Well, if we look, this is normal. And let's go back. So we're looking at sickle cell anemia. Sickle cell anemia is a recessive blood disorder. So if you're a carrier, that means you carry a copy of the disease gene. This parent, this female, has 2 normal, and this the father is a carrier. So that would be generation 1, individual 2. So we're going to write 1, Roman numeral 1, and these are Roman numerals, by the way. Individual 2. So that's how we would answer that question. How many offspring from generation 1 inherited the sickle cell allele? So there are 3 offspring. Remember, these are marriages. These do not, there's no line attaching these people to the parents. So what we see is that, bad luck, every child from this mom and dad got a copy. So how many inherited the sickle cell allele? 3 of them. Which individual in generation 2 marries a spouse who is homozygous dominant? So which individual in generation 2 marries a spouse who is homozygous dominant? So let's say, let's go with A is normal and lowercase a is sickle cell. So that means that the mom is homozygous dominant and the dad is recessive. So in generation 2, the only one who's homozygous dominant is here. They want to know which individual marries a spouse who is homozygous dominant. So it would be generation 2, individual number 1 marries the homozygous dominant spouse. In which generation does the first case of sickle cell anemia appear? Well, we've got carrier. Oh, here's somebody who has the disease. So they're AA. So that's going to be in the 3rd generation. I'm going to go ahead and read the question. Well, I can scroll down a little bit. without cutting off. In which generation contains the most male carriers? All right, so here we have 2 female carriers and 2 male carriers. Here we have 2 female and 2 male. And here we have, 3 male. Here we have 1, 2, 3 female and 1 male. So it's going to be in generation 3. Have any individuals had incestuous relationships? And if so, which ones? Okay, this is going to be interesting. So this is a sister, a brother, a brother. If we look at their offspring, they had a girl, a boy, a girl, a boy, a girl. Uh-oh, look what happens. Do you see this line here? These guys came from the same branch. And so this means a brother and sister got married. Ooh. So it's going to be a generation 3, individual 2, and generation 3, individual 3. All right, I'm going to go ahead and read the questions now because we don't want to lose sight of this. So question 8 says, can 2 carriers produce an individual with sickle cell anemia? And so let's look for an example. Let's look for the people who have sickle cell and their parents. Yep, they both had an allele. They were carriers. So the answer to number 8 is yes. Question 9 is, can a normal homozygous individual produce offspring with sickle cell anemia? In the answer here, so here's a homozygous. None of the children have it, but we have a lot of carriers. Here's a homozygous parent. None of the children have it, but there's a lot of carriers. Here's a homozygous parent, and here are heterozygous. There you have a child. So you have to have 2 parents who are either afflicted or carriers to have it. So the answer to number 9 is, can a normal homozygous individual produce offspring with sickle cell anemia? And the answer to that is no. Question number 10. Which parents produce 2 children with sickle cell anemia? Well, we need to look for the afflicted. So I've got afflicted here. I've got an afflicted here. These 2 parents have 2 kids that have it. So you would say generation 3, number 8. And generation 3, number 9. It's a 9. And then finally, if individual generation 4-1, so if this individual mates with a male carrier for sickle cell anemia, what is their chance their first offspring will have sickle cell anemia? So what they're saying is, if this person is a female, if we do this cross, what's their chance of having an offspring? What we're going to see is we have AA, and if we do this, we're going to see that we have so we would have 25% would be normal, 50% would be carriers, and 25% would be afflicted. So the answer to number 11 is 25%. All right, I hope that gets you warmed up with pedigrees. You're going to do some practice problems for homework. And in the next video, we're going to start, I think we'll just call it, we'll call this 702, and we aren't going to do a part 1, part 2. 703, we're going to look at a different type of pedigree. All right, that's it for now.